Washington State University. Go Cougs!
Hello everyone. In this video, we're going to cover Lesson 3 of the Activity Change Detection module. We're going to discuss what an activity density map is and how we can create one. In the second part of this lesson, Lesson 4, we're going to learn how we can beautify our activity density maps with really nice informative labels. Without any further ado, let's get started learning about activity density maps. An activity density map is also known as an ADM, and it's a heat map that was originally proposed by Wong and colleagues in 2012. Wong and colleagues used an ADM to visualize the daily activity of a smart home resident as a function of 24-hour time and daily window time. I've included 2 of the ADMs from the original paper. If you'd like to check out the original paper and see these images more clearly, please take a look at the link I've included here. Now let's take a look at the ADM on the left side. On the x-axis are days in a month. On the y-axis are hours of the day, all 24 hours, and each cell has a color. The color corresponds to the activity level of the resident in their home. White represents little to no activity, and blue represents very high activity. In between white and blue are other colors to represent other levels of activity. Black is a color reserved to represent when the resident is out of their home. So for these black cells here, we don't know what the activity level is. Now, with these 2 plots side by side using the same color scheme, we can see that the left plot represents an individual who is highly active. There are lots of yellows, greens, and blues, whereas the right plot represents an individual who is sedentary. There are very few greens and blues, mostly yellows. We're going to adopt Wong and colleagues ADM in order to visualize longitudinal Fitbit data. In the previous lesson, we learned how to download minute-by-minute Fitbit data from the Fitbit API. We stored this data in a DataFrame, and then we wrote this DataFrame out to a CSV file. If we were to call this code for multiple subsequent days, then we would end up with a longitudinal Fitbit dataset. We can visualize this longitudinal Fitbit dataset specifically for the steps metric or the heart rate metric, etc., using an ADM. By the end of the next lesson, we will have created an ADM that looks like this using Matplotlib. Let's get started discussing the data set we're going to use to make such an ADM. I've gone ahead and created a zip file called fitbitexampledata.zip that I encourage you to download and extract. In this folder, you will see 21 CSV files representing 21 days of example Fitbit data from a volunteer. The format of each one of these CSV files is exactly the same as we were writing out in our previous lesson. Here I have some code that is going to open the directory, Fitbit example data, and create an ordered dictionary where each key in the dictionary is a string representation of a date, and each value in the dictionary is a data frame for that date. Now this code here walks through all of the files and directories in this directory here and loads up each one of those CSV files using pandas.readCSV. One thing I'd like to note is here I've added code to set the index of each data frame to a date-time index. This will make resampling in the future much easier. Then we go ahead here and add to our order dictionary the date as a string mapping to the data frame with a date-time index. Now after we run this code, we have all the data read in our intraday files dictionary. Now we want to construct a data frame where we have columns that represent daily steps and index that represents each minute of a day. So in order to do this, let's go ahead and grab the first days string representation. So 10/1/2015. And we'll use this as a quick and dirty way to get the index for our data frame. So our steps data frame will be pd.dataframe, and we're going to set it to be empty, but we're going to set its index to be the same index as interday files subday.index, day 1. Now all we have to do is go through each day and data frame pair in our interday files and add one column at a time to our steps data frame. And let's print out our steps data frame, head to the first 5 minutes, and here we see the first 5 minutes, and all of our columns are daily steps. So far, so good. While we're at it, let's go ahead and write this data frame to a file. I'm going to put it in the same directory at which we read in the CSV files. So that's data_dir plus underscore steps df.csv. Now this is there for future use in a future lesson should we need it. Now we're ready to construct our ADM. I'd like to point out that we're going to construct this ADM for steps based on our steps data frame we've built here, but we could have chosen any of our columns in our original data frames we were reading in here, such as calories or heart rate. So first things first, let's set up our matplotlib code. Okay, now I'm going to make a function called ADM in order to make our ADM so that it's reusable. So ADM is going to accept a data frame, a label for the title, and a flag whether or not to show this plot now. Perhaps we might want to show it later. We'll go ahead and give references to the current figure and axes for a new subplot. We'll get a color map for visualizing our intensity levels, and we can do that with plot.getColorMap and then specify a string for a color map. Now, if we go to a color map example on the Matplotlib website, we can see there are several color maps we can choose from. I'm choosing the reds one here, but you're welcome to choose any one of these that you would like. Once we've chosen our color map, then we can create the heat map and set the heat map's color map to be CMap. So let's go ahead and call plot.imageShow. This will make our heat map, passing in our data structure, data_df. We're going to set interpolation to be none, and I'll explain this here in a second. We'll set aspect to be auto, so we can see all of our ADM. And we'll set our color map to be CMap. Now let's add a color bar, which is going to be our color scale on the right side of our plot. Let's set that to appear. Let's set the X label to be day. Let's set the Y label to be time. Let's set the title of our plot to be that title label parameter. And I'm also going to set the size of this figure to be a little larger than default. briefly because I want it to be nice and wide to fill up our notebook and so we can see the data more clearly. If show is true, then let's go ahead and show this figure. And I'm going to return the figure and axis references because in part 2, we're going to need them when we add our bells and whistles to our initial ADM we are about to construct. So let's go ahead and call ADM, passing in our steps df and a label called steps. So here is our part 1 initial ADM. As you can see, we have our color bar on the right using the red color map. We have days on the bottom that are currently sequentially counted, 0 through 20 for 21 days. On the left side, we have time, which currently is sequentially counting 0 to 1,439 for 1,440 minutes in a day. Now I'd like to take some time to briefly explain what interpolation is here. With interpolation set to none, there are no transitions between the color values on our heat map. Say we set interpolation to something like bilinear, then we're going to see some interpolation occurring between our values and thus between our colors to get kind of a blurring effect. So depending on what version of Matplotlib you're running, you may want to make sure that you set interpolation to none, just so that for sure we don't have the transitions between colors. Now the last thing I'd like to mention in this video is while this ADM does work, it's missing some really important labels on our x-axis and our y-axis that could help us find out more information from this ADM quickly. So in our next lesson, we're going to beautify this plot by adding labels for the x-axis. So we'll change the day counts down here to be date strings, and we'll add day of the week on the top, such as Monday, Tuesday, Wednesday, etc. We're also going to add y-axis labels to the left side and the right side of our plot, representing the hours of the day, such as midnight, 1 a.m., 2 a.m., etc. And lastly, we'll add grid lines so that we can more easily see cells in our heat map, just like our example from Wong and colleagues and the final example that I have showed here.